Welcome! In this video, we'll explore the layout of a fruit juice processing plant, step by step, from raw fruit reception to packaging. By the end, you'll understand the key areas, their sequence, and why layout matters for efficiency and safety.
Plant layout defines how materials, machines, and workers move. A good layout ensures smooth flow, minimizes contamination, reduces cost, and saves time. Every juice plant begins with receiving raw fruits. Here, trucks unload fruits into the reception area. The fruits go through sorting and washing to remove dirt, debris, and pesticide residues. Next, fruits are peeled and cut. Depending on the fruit type, mechanical pulpers extract the pulp. This section must be hygienic and well ventilated. The extracted juice undergoes pasteurization, heating to destroy harmful microbes. Proper layout ensures that pasteurizers are close to the pulping section but isolated from raw areas to prevent cross-contamination. After pasteurization, juice is filled into bottles, Tetra Paks, or cans. This section requires sterile conditions. Automated filling lines and packaging machines are arranged in sequence for smooth flow. Storage and dispatch. Finally, packaged juice is moved to cold storage or dry warehouses before dispatch to markets. Proper storage ensures product quality and shelf life. Here's the flow of a fruit juice processing plant. Keycap 1 Raw material handling. Fresh fruits are received, washed, and prepared. Keycap 2 Crushing and extraction. Fruits are pulped and juice is separated. Keycap 3 Primary treatment. Juice undergoes filtration, heating, and homogenization. Keycap 4 Advanced processing. Sterilization, blending, and evaporation extend shelf life. Keycap 5 Concentration and drying, optional step to make juice concentrates or powders. Keycap 6 Packaging. Juice is filled into bottles, cartons, or pouches. Keycap 7 Testing and dispatch. Quality checked products are stored and sent to markets. This systematic flow ensures safe, hygienic, and high-quality juice production. Key takeaways and wrap up. To recap, fruit juice plants must have a hygienic, efficient, and linear layout. Proper zoning reduces risks and boosts productivity.
Safety considerations in layout. Worker and equipment safety is critical. Layouts should include wide aisles, emergency exits, fire safety systems, and clearly marked zones for chemicals like cleaning agents. Quality control and lab section. Most juice plants have a quality control laboratory located near the processing line. Samples are tested for pH, sugar content, microbial load, and packaging integrity. Placing the lab close by ensures faster feedback. Employee facilities. Separate facilities for staff are essential. Locker rooms, hand-washing stations, and cafeterias should be placed outside processing zones but close enough for convenience. This helps maintain hygiene and worker morale. Environmental and sustainability aspects. Modern plants consider sustainability. Solar panels, water recycling systems, and byproduct utilization, like turning fruit peels into pectin or animal feed, reduce environmental impact and add value. Case example: small mobile juice plant. A new trend is mobile juice plants, small units mounted on trucks or containers. These are useful during fruit harvest seasons in remote areas. Layouts are compact, but still follow the same raw to packaging sequence. Final recap plus quiz. Let's summarize. A fruit juice plant layout covers raw reception, washing, pulping, pasteurization, packaging, and storage. It must follow hygiene zoning, safety, and sustainability principles. Now, pause and answer. Why should pasteurization be separated from raw areas? What is FIFO in storage? Give one sustainable practice in juice plants. Fruit juice plant layouts. Small versus large scale. We'll compare layouts of small scale and large scale fruit juice processing plants. You'll learn the differences, advantages, limitations, and which suits different business goals. Introduction to scale. Plant scale affects cost, equipment choice, automation, labor, and efficiency. A small-scale unit might process just 500 liters per day, while a large industrial plant may handle thousands of liters per hour. Small-scale plant. Characteristics. A small-scale juice plant is typically semi-automatic, requires lower investment, and is ideal for startups, local markets, or seasonal fruit utilization. Space requirement is smaller, and operations are simpler. Small-scale layout. Step by step. Here's a typical flow: reception, washing, manual cutting and pulping, pasteurization in small kettles, hand filling and capping, storage. The focus is on low cost, flexibility, and direct market supply. Large-scale plant. Characteristics. Large plants are highly automated, need high capital investment, and serve regional or global markets. Layouts prioritize efficiency, hygiene zoning, and bulk storage. They often run continuously with high throughput. Large-scale layout. Step by step. The layout includes automated fruit unloading, conveyor washing, industrial pulping lines, continuous pasteurizers, automated filling lines, robotic packaging, cold storage and large dispatch bays. This design maximizes output while maintaining strict food safety standards. Key differences, side by side, of small and large-scale plant. Small-scale plants rely on manual labor, low investment, and flexible production, while large-scale plants rely on automation, higher investment, and efficiency at scale. Small units serve niche markets, while large units serve mass consumption. Case example: small plant. For example, a village-level mango juice plant can process 1 ton of fruit daily using simple pulpers and gas pasteurizers. The juice is sold in bottles to nearby towns. Case example: large plant. On the other hand, multinational juice brands like Tropicana or Real set up plants processing hundreds of tons daily, with automated lines, aseptic packaging, and exports worldwide. Choosing the right scale. Scale choice depends on capital, target market, availability of raw fruits, labor, and demand. Many entrepreneurs begin small and expand as demand grows. Key takeaways and wrap up. In summary, small plants are cost-effective and flexible but limited in capacity. Large plants are efficient and scalable but require heavy investment. Understanding these layouts helps design facilities suited to specific needs. Next, we will continue with improvements and expansions in plant design for juice processing. Introduction. In our next video, we'll explore improvements and expansions in plant design. As juice demand increases, plants must scale up, modernize, and optimize their processes. Today, we'll look at how small units evolve into large-scale, efficient operations. Why expand? Expansion is driven by rising consumer demand, competition, food safety requirements, and export opportunities. A plant that processes 500 liters per day today may need to process 5,000 liters tomorrow. Upgrading equipment. Small plants often rely on manual equipment, but as production scales, semi-automatic or fully automatic systems are needed. For example, manual pulping can be replaced with mechanical pulpers that handle several tons per hour, improving consistency and hygiene. Improved process flow. A small unit may have a linear, manual flow, but larger plants use layout optimization. Raw material reception, processing, filling, and storage are designed for minimal movement and maximum efficiency. Energy and water efficiency. Expanding plants must also think about sustainability. Modern facilities recycle process water, use energy-efficient boilers, and recover heat from pasteurization systems. Hygiene and food safety. With expansion comes stricter hygiene needs. Stainless steel piping, clean-in-place, CIP, systems, and HACCP-compliant layouts reduce contamination risks. Automation and digitalization. Automation transforms plant efficiency. From digital sensors monitoring pasteurization temperature to SCADA systems controlling the entire line, expansion brings Industry 4.0 into food processing. Packaging innovations. As plants expand, packaging must also evolve. Instead of manual glass bottle filling, automatic PET bottle lines, aseptic cartons, and shrink wrapping systems are introduced. Workforce and trainings. Expansion isn't just about machines, it's about people. Workers must be trained in safety, machine handling, and quality control for smooth operations. Case study example. Let's take an example. A small fruit juice unit in Maharashtra started with 500 liters per day, using manual pulping. Within 5 years, they expanded to 10,000 liters per day with mechanical pulpers, automatic pasteurization, and aseptic PET bottling. Their market grew from local shops to exports. Future directions. The future of plant expansion lies in sustainability and smart technologies, AI-driven predictive maintenance, blockchain for traceability, and green packaging materials. Supply chain integration. Plant design doesn't stop at the factory walls. Modern juice plants are integrated with supply chains, from farmer collection centers to cold chain logistics. This ensures raw fruits reach the plant fresh, and finished products reach markets efficiently. Waste management and byproducts. A major expansion consideration is waste handling. Skins, peels, and seeds from fruits can be turned into pectin, animal feed, or bioenergy. This not only reduces waste but adds revenue streams. Cold storage and distribution hubs. As plants scale up, storage and distribution hubs become critical. Cold warehouses, reefer trucks, and regional hubs extend shelf life and expand market reach. Expansion challenges. Expanding a plant is not without challenges. Capital requirements, skilled labor shortages, and compliance with stricter regulations often slow down projects. Successful expansions balance these challenges with careful planning. Role of government and policies. Government plays a major role in supporting expansions. Subsidies, food parks, export promotion policies, and renewable energy schemes create opportunities for juice plants to modernize and grow. Digital twin and simulation. One exciting innovation is the use of digital twins, virtual models of juice plants. These allow managers to simulate process changes, test layouts, and optimize efficiency before investing in physical infrastructure. Global trends in plant design. Globally, fruit juice plants are moving towards sustainability, traceability, and customization. From blockchain for food safety to personalized nutrition juices, the next decade promises rapid transformation. Safety and hygiene standards. An essential part of plant design is ensuring worker and consumer safety. Juice plants follow hygiene protocols like foot baths, protective clothing, and pest-proof facilities. Designing with safety in mind protects both the product and the people who handle it. Economic and market considerations. Designing a fruit juice plant is not just about machinery, it's also about economics. Small-scale plants focus on direct sales and local markets, while large-scale plants aim for exports and branding. Market analysis and cost-benefit planning are crucial steps before expansion. Future trends in plant design. Looking ahead, the fruit juice industry is adopting smart technologies. IoT sensors will allow real-time monitoring, AI will optimize production schedules, and robotics will handle repetitive tasks. Plants of the future will be digital, sustainable, and globally connected. Final summary and closing. In this video, we explored the fundamentals of juice plant layouts, compared small and large-scale facilities, and discussed improvements and expansions. We also looked at safety standards, economic planning, and future trends. From farm to bottle, every design decision shapes quality, efficiency, and sustainability. Today we explored the basics of fruit juice processing plant layouts, from raw material reception to final storage. We compared small-scale and large-scale plants, highlighting their unique advantages and challenges. Finally, we looked at how improvements and expansions in plant design can boost efficiency and meet growing demand. If you found this video helpful, Don't forget to like, share, and subscribe for more food technology insights. Stay tuned. Together, let's keep learning and innovating in the world of food technology.